In today's data-driven world, understanding the concepts of structural and data dependence, as well as data redundancy and data anomalies, is crucial for optimizing database design and ensuring data integrity. Hi, my name is Clarence Magallanes from BSIT 24. We are from Group 1, and our report is all about understanding structural and data dependence and data redundancy and anomaly. This report delves into these fundamental aspects of database management systems, also known as DBMS, offering a comprehensive overview of how they impact data organization and retrieval by examining the intricacies of structural dependence, which refers to how changes in database structure affect data access and manipulation, alongside data dependence, which involves how data retrieval is contingent on specific data structures. We aim to highlight the significance of minimizing these dependencies. Additionally, this report will explore data redundancy, the unnecessary duplication of data, and data anomalies, irregularities that compromise data consistency. Understanding these elements is essential for designing efficient, reliable, and scalable database systems. But before we start, let us have our essential questions for this report. How do we define structural and data dependence? When does data redundancy occur? When does data anomaly occur? And our intended learning outcomes for this report are the importance of structural and data independence, as well as data redundancy and data anomaly, and how it should be avoided.
We have two types of dependence, structural and data dependence. Let's start by talking about the former. What comes into your mind when you hear this word? Dependence is like a vine that wraps itself around the tree. The vine relies on the tree for support. Without the tree, it can't grow or reach sunlight. Similarly, in any context, when something is dependent, it means it can't function or thrive without relying on something else, just like the vine needs the tree to climb. Structural dependence in the context of file systems means that the way you access and manage data is tightly linked to how that data is organized within the file, or in other words, it's dependent on its structure. In simpler terms, if the layout or organization of the data within the file changes, the way we access that data also has to change. Here's a simple analogy to understand it better. Imagine you have a bookshelf with books organized in a specific order, let's say by genre, then author, and finally by title. Now, if you decide to reorganize the books by author first, then genre, and finally by title, anyone looking for a book would need to know the new order to find what they're looking for. If they still try to find the book based on the old order, they will be lost. Suppose you have a database table for storing customer information with fields like customer ID, first name, last name, and address. If you decide to add a new field for phone number between last name and address, every application or report that reads this data would need to be updated to reflect this change. If you don't update the applications, they might not function correctly as they are dependent on the original structure of the table. This is structural dependence in action.
Structural independence is the ability of a database system to change its structure without requiring modifications to the applications that access it. In other words, you can adjust how the data is stored, such as adding new tables, resizing fields, or renaming columns, without having to rewrite or extensively change the programs that use the data. And the benefits of it are easier adaptation. The database can be modified as business needs, changed without causing problems for existing applications, making it easier to adjust to new requirements. And the second one is lower maintenance costs. Applications don't need constant updates when the database changes, reducing the time and money spent on maintenance. And the third one is better growth. The database can expand or change over time without needing major rewrites of application code, making it easier to scale. The fourth one is more reliable data. Structural independence helps keep data accurate and consistent even when changes are made to the database. Smooth and the last one is smoother upgrades. Upgrading the database or making structural changes can be done with minimal impact on the applications that use it, making the process more straightforward.
What is data dependence? Data dependence refers to the relationship between the data and the application that access it. It describes a situation where changes to the data structure, such as the schema modification, necessitates corresponding changes in the application that interacts with the data. Imagine you created a simple calculator program that only works with numbers. For example, it can add 2 plus 3. The program only expects you to enter numbers like 2 and 3. If you type in 2 plus 3, it will give you the correct answer, 5. However, if you put 2 plus a instead of numbers, the calculator might crash or show an error, as it wasn't designed to understand letters.
Data independence is another concept that allows for changes to be made in the database schema or structure without affecting the way data is accessed or presented to users. This simply means that you can modify or update the database without disrupting its functionality. In this way, large and complex databases become more flexible and easier to manage.
So now let's move on to the practical significance of data dependence. So the practical significance of data dependence lies in understanding the distinction between the logical data format and the physical data format. To fully understand, let's break down these two, which are the logical schema and the physical schema. So first, what is logical data format? So the logical data format describes the structure of data as understood by the users and applications, independent of how it is physically stored. It includes the data types, relationships between data items, and the rules governing data integrity. So next is the physical data format. Refers to how data is actually stored on a storage medium such as a hard drive or cloud server. This includes details like formats, data compression, indexing methods, and how data is retrieved and updated. So here's an example to fully understand what is logical and physical data format. So in a library catalog, books are organized into categories like fiction, nonfiction, science, and history. Each book is listed with details such as title, author, publication date. This is the logical data format, how data is organized in a way that makes sense to users. When you search for a book by its title, you're interacting with this logical format. So behind the scenes, all this book information is stored on a server, either in a school data center or in the cloud. The server uses files, databases, indexes, and backup systems to manage and protect the data. Although users don't see this physical format, it what enables the system to quickly find the book you're looking for. So in easy words or sa madaling salita, the logical format is like the organization of the books in the catalog. It's about how the information is grouped and how different pieces of information relate to each other. Then the physical format is like the actual shelves or databases where the books are stored. It's about the technical details of storage which you don't see but are essential for the system to function.
In the figure shown, we can see the concept of data independence. The logical schema refers to the structure of the data or the stored information, while the physical schema refers to how data is stored. When we say a database has logical data independence, it means that we can change the logical schema, such as adding new fields or tables. However, the changes we made do not affect its physical storage. On the other hand, when we say physical data independence, it means if you want to make changes in the physical storage, such as upgrading the hardware to improve its performance, it would not affect the logical structure. Also, the way we view the data stays the same.
Data redundancy occurs when the same piece of data is stored unnecessarily in multiple or different places. This duplication can lead to inconsistencies, increased storage costs, and difficulties in managing and updating data, as changes need to be made in every location where the redundant data exists. Uncontrolled data redundancy also sets the stage for data security and data inconsistency. Poor data security happens when having multiple copies of data increases the chances for a copy of the data to be susceptible to unauthorized access. Data inconsistency exists when different and conflicting versions of the same data appear in different places.
Data integrity refers to the accuracy, consistency, and reliability of data throughout its life cycle. It ensures that the data in a database is correct, reliable, and valid, and that it remains so during any operations, such as updates, insertions, and deletions. This concept ensures that the information stored remains correct and trustworthy, even as it undergoes various operations. By maintaining data integrity, organizations can ensure that their database consistently provide dependable and accurate information, which is critical for informed decision making and effective data management. Next is the importance of data integrity. It ensures that the data can be trusted for analysis and decision making, helps in maintaining the correctness of the data, which is essential for accurate reporting and analytics. It prevents anomalies and inconsistencies that could lead to faulty conclusions, helps in meeting regulatory and legal requirements by ensuring data is managed properly. So, in conclusion, data integrity is essential for ensuring that the information within a database is trustworthy and reliable, forming the foundation for accurate analysis, reporting, and decision making. By maintaining data integrity, organizations can avoid costly errors, meet regulatory and legal standards, and ensure that their data driven insights are both valid and actionable. Lastly, characteristics of data integrity, which involves accuracy and verifiability. First is accuracy. The data must correctly represent the real-world entity or scenario it is intended to model. Any inaccuracies must be corrected to maintain the integrity of the database. Number two, verifiability. In data integrity, it ensures that data can be consistently checked, validated, and trusted, reinforcing its accuracy and reliability within the database. So when we say accuracy, for example, a customer changed his or her name within a database. Dapat lagi lang siya ma-update or it will cause nuisance or a problem within the system. Sa verifiability naman, sinasabi doon na yung data within the database ay dapat laging check, validated tsaka trusted. So, sinasabi doon na dapat yung data is trustworthy and reliable. So, dapat yung data na binigay ng customer, for example, is totoo and hindi lang siya gawa-gawa. Kasi hindi lang naman sa isang table or sets makaka-apekto yun.
So let's move on to data anomalies. Data anomalies develops when not all of the required changes in the redundant data are made successfully. First, when we say anomaly, it is something that deviates from what is normal or what is regular. So, for example, when we have a group of 5 kittens and there is a one puppy, so that one puppy is a anomaly for that group because we expected to have only kittens since it is a group of kittens, so we don't expect it to have a puppy. Data anomalies refer to inconsistencies or errors that arise when performing database operations like inserting, updating, or even deleting data. These anomalies typically occur in databases with redundant data or poor design, leading to situations where the data does not accurately reflect the real-world conditions it represents. So, data anomalies can result to loss of data integrity, can cause errors, inconsistencies, and also unreliable information. So for the types of data anomalies, first we have insertion anomalies. When we say insertion anomalies, it occurs when new data cannot be added to a database without additional, potentially unrelated information. This problem arises due to the design of the database where certain attributes are required even when they are not available or applicable at the time of data entry. So, sa, so in insertion anomaly, we can experience insertion anomaly when we insert a set of data, but we are lacking in certain category. Just like in this example, if a student detail has to be inserted whose course is not being decided yet, then insertion will not be possible till the time course is decided for the student. So we insert a set of data for the student, for a new student. However, we are lacking data for the category of course. So this table shows an insertion anomalies because we are lacking data. So the table creates inconsistency. So another example. So we have here our table for the order ID, customer name, customer phone, the product name, quantity, and order date. In our first set of data, we have complete details. However, when we try to insert the data for Justin Barbie, we uh we lack data from the product name, quantity, and order date. So we have no data for these three fields. So we experience insertion anomalies since we have no data and we have incomplete data, and it creates inconsistency in this table. So in order to resolve it, we can create two separate tables for the customer ID and one for the order table. So we can simply put the information of our third data set without worrying if we lack the data from the product name, quantity, and order date. So let's move on for the second type. We have update anomaly. When we say update anomalies, it occurs when changes to data are not correctly propagated throughout the database, and it will lead to inconsistencies. This happens when the same piece of data is stored in multiple places and an update is made in one location but not in others. So in our example, we will only use the one table. So we got here in our example, suppose if the rank of the college changes, then changes will have to be all over the database, which will be time consuming and computationally costly. So if we have to update the rank, which is this one. So suppose we will update it from 1 to rank 3, since they have the same college, we will update the college rank. They have the same college, so we will update it one by one. It will be time consuming, and also in order to prevent update anomaly, all data should be updated into the new data, which is the rank 3. Now for the deletion anomalies, it happened when the deletion of a piece of data it advertently results in the store in the loss of additional unintended data. This issue often arises when data is overly interdependent or stored in a non-normalized form. So example, if the details of the student in this table are deleted, then the details of colleagues will also get deleted, which should not occur by common sense. This anomaly happens when the deletion of a data record results in losing some unrelated information that was stored as part of the record that was deleted from the table. So, in this example, we will use this database. So, we say tablet and 1, 8, 26, 24. So, suppose that we will delete this data for Justin Barbie. So, we deleted it because we suppose that the product has been or the order has been cancelled. But we wanted to keep the information so when Justin wants to order again, the information of him will be recorded. So in order to prevent it, we will create two separate tables. So we can keep the information of Justin and we can delete the order details of him.